Jai Hind, dear students. I hope so you have saw the previous videos and have learned what are square numbers and their properties. So in this video we are going to start our first exercise, that is exercise 6.1. So let's start with question number 1. Question number 1 says that what will be the unit digit of the squares of the following numbers. So we are given this 10 numbers, and for each of these numbers we have to find unit digit of the square of that number. So let us start with the first part. In first part we have 81, and the unit digit of 81 is 1, right? So the unit digit of the square of 21 will be 1 square, or 1, as 1 times 1 gives you 1 only. So this will be your answer. So basically what to do in this question, we have to find unit digit, right? To find the unit digit of the squares, we are not going to square the whole number. Just we need to find the square of the unit digit so that we can find the unit digit of the result also. And then as you can see, we have not done a square of 81, we have done a square of 1, and we get 1 as our answer. Now let's move to part 3. In part 3 the number is 799, and if you will find the unit digit, 9 will be your answer. I think so you're also doing with me, right? So now when we find the square of 9, 9 times 9 will give you 81. And as you can see, 81 is having unit and tens place both, but we need only unit digits. So 1 will be your answer. Clear what to do? So in this way we will find the unit digit of the squares. Isn't it so easy? Just you need to find the square of the unit digit, and yes, in the result you will get the unit digit of the square of that number. How amazing, right? Now what I'm thinking, let's do all the questions for your better understanding, but you have to do in your copy according to your syllabus. Now moving to part 5. In part 5 we have 1, 2, 3, 4 as our number. Now think how difficult it will be to find the square of this. But as you can see, 4 is the unit digit, so we will find the square of 4. That will be on 16, and just find the unit digit of 16. And yes, you are correct. 6 will be your answer. So the unit digit of square of 1, 2, 3, 4 is 6. Clear? Now, sixth part. What to do in sixth part? Same. The number is 2, 6, 3, 8, 7. To find the unit digit of the square of the number, what we are going to do? Yes, we are going to do the square of unit digit. So 7 square will gives you 49, and the unit digit of the square of this number will be 9. Clear? I think so now you are understanding, right? So let's move to the next part. Also I want to add that while watching the video, please try to do by yourself first and then check your answer. Then this part is having 52698 as our question. We have to find the unit digit, so 8 is our unit digit. If you will do the square of 8, you will get 64 as your result. So the unit digit of the square of this number is 4. Correct? And I think so you've already done that before me. Yes? So now moving to the next part. In next part we have 9, 9, 8, 8, 0 as our number. So as we can see here, 0 is our unit digit. So the square of unit digit will be 0 only. Hence whenever you will see a 0, so result of the unit digit of the square will be also 0. Now moving to the ninth part. In ninth part we have 12796 as our number. Now as you can see, 6 is our unit digit. So the square of 6 will be 36, and hence the unit digit of the square of this number will be 6, and hence in this way we will do this question, and I hope so you have understood also. Now let's learn how to solve question number 2. In question number 2, the problem statement says the following numbers are obviously not perfect squares. Give reasons. Also we have 8 parts in this question, and they are not perfect squares, and without any calculation we have to specify that why they are not perfect square. We have to provide the reason behind it. So before we analyze each numbers, let's first look at this incomplete table in which first row is having number ends in from 0 to 9, and the numbers that are present in the first row from 0 to 9, you could have all the digits from 0 to 9. That could be the unit digit of the numbers, and the second row stands for the unit digit of the square of the number. So now let's complete the table. For example, starting from the first, if the numbers ends in 0, then the square of that number will also ends in 0. So the unit digit will be 0. Now if the number ends in 1, then square of that number will also ends with 1, as 1 times 1 is 1. 2 square will gives you 4, so the square ends in 4. 3 square will gives you 9, so the square ends in 9. 4 square will gives you 16, so the square ends with take only unit digit. So 6 will be your answer. Clear? We are having 2 digit over here, so we'll take the ending digit only. Now 5 square gives you 25, so the ending digit is 5 only, so the square ends with 5 or 5 square. Now if I talk about 6 square will gives you 36, and if we will take the unit digit, then square ends will be 6. So the unit digit of 36 will be 6. Not talking about 7. 7 square will gives you 49. So the unit digit of square of 7 will be 9 only. Understood what to do? And how to find it, most important. Now 8 square will give you 64, so 4 will be the unit digit here. Now if we will do the square of 9, 9 times 9 will gives you 81, so square of 9 ends with number 1, so 1 will be the unit digit of the square of 9. So the possible unit digit of any square numbers are listed in the second row. So we have 0, 1. As you can see also 1 is occurring twice, then 4 is also occurring twice, then 9, same with 9, it is occurring twice, then 6 2 times, and 5. Now if you will properly see the second row of a table, some digits are missing from here. So we don't have 2, 3, 7 and 8. So the number ending in these digits 2, 3, 7, 8 can never be perfect square. So what this table tells us, and this observation what we can apply in our present question. For 1057, just check out its unit digit or the ending number. So 7 as you all know, 7 is a number which is not a perfect square, because, or in the solution part you can write, since it ends in 7, that's why it's not a perfect square. Understood? So it is very important to understand that what number should be present at the unit place to make that number a perfect square. So if the numbers end with 0, 1, 4, 5, 6 and 9, that number will give you perfect square number. Otherwise, if it is having 2, 3, 7, 8 at the unit place, then it will give you non-perfect square number. So moving to part 3. In part 3, we have 7, 9, 2, 8 and the unit digit of this number is 8. As we have learned, a perfect square cannot have 8 at its unit place, so this is not a perfect square. So we'll write it also since it ends in 8. Clear? Now, in fourth part, we have 6 times 2, right? So let me write 1, 2, 3, 4, 5, 6. So this is your number. Now if you will see, 2 is the ending number, and as we have learned, ending with 2 will not give us perfect square number. So we'll write it is not a perfect square since it ends in 2. Understood? I hope so. Till now you're understanding everything, that how to proceed in the question. If you haven't understood, please watch the video again and try to understand the concept. Now, in part 6, the number is 8972. And as we have understood that 2 cannot be the unit digit of a perfect square number. Therefore, for this part, we can say that obviously this part will not be a perfect square, and we will write 89722 is not a perfect square since it ends in 2. Right? So this is the reason why this number cannot be a perfect square. Now let us do some more parts, like in part 5th, in part 7 and in part 8, the numbers are ending with 0. And also we have learned that 0 can be the unit digit of a perfect square numbers. Right? With the use of table, we can also see that the numbers ending with 0 can also have 0 at their unit places in their square. Then the main question is, what is the reason that these three numbers are not perfect squares? Well, to answer this question, we have to look at how many zeros are there at the end of these numbers. So let us check out these parts also. In the fifth part, we have 64000. Now, if you will count the zeros, there are 3 zeros in fifth part. So the main concept behind this is, if a perfect square number ends in a 0, then number of zeros at the end of the number must be even. To understand this concept, let us take one random example. So if I take example as 500, and if we will do the square of this, for 5 square we have 25, and these 2 zeros will become 4 zeros on squaring. And as you can see, we have even number of zeros. Now let us take one more example. Let's take 70. Okay, now if you will do the square of 70, what you will get? Yes, 7 square will gives you 49, and then this 1 0 will become 2 zeros. So again you have an even number of zeros at the end of the square. So whenever you have zeros at the end of a perfect square, the number of zeros must be even. Clear? And this is the observation we will apply in our rest parts. In part 5, if you will see, we have 3 zeros and 3 is not an even number. So we will directly say that this number is not a perfect square, and in reason we can write since it ends in 3 zeros. Clear? That's why instead of having 0 at the end of a number, it is not a perfect square. Understood? So whenever you will find any 0, don't directly say that this is a perfect square. First of all, you need to count the number of zeros. If the number of zeros are even, then only we will say that yes, this is a perfect square. And I hope so by using this concept you can easily do rest part of the question. One more thing, you have to solve questions according to your syllabus. Okay? For more command on this type of questions or any questions of the chapter or the exercise, it is very important to do the practice. What you can do? Just you can pause the video, try it by yourself, then if any difficulty occur, then see the video. Otherwise, just complete it by yourself and then in last check out the result. Also, if you have any side book or extra questions related to the chapter, please try to solve it. If you feel any kind of difficulties on any topic or at any step, just feel free to ask. We are here to help you. But before that, it is very important in this chapter, or I can say for any chapter, to first of all understand the concept behind it and then try to do that question by yourself. So I hope so you have understood. So let's learn how to solve question number 3. So question number 3 says that we have to find the squares of which of the following will be odd numbers. So we have these 4 numbers. First is 431, second is 2826, third is 7779, and fourth is 82004. So without doing any calculation, we have to determine whether the squares of each of these will be an even or odd natural number. To do that, let's analyze the ending digits of the squares of an odd number. So if you will take any odd number, then its unit digit will be 1, 3, 5, 7 and 9. And if you will find the square of these numbers, and we will write only the unit digit or the ending digit of it. So 1 square will give you 1, 3 square will give you 9, 5 square will give you 25 and 5, 7 square is 49, so 9, and 9 square is 81, so 1. So what we have observed? We have observed that if we will do the square of any odd number, we will get 1, 9, 5, 9 again, 1 again as our ending digits. So on observation we can conclude that square of any odd numbers will be the odd numbers, right? Now let us see for even numbers also. What happens when we will do square of an even number? So what could be the ending digit of an even number? It could be 2, It could be 4, 6, 8 or 0, right? Now, if we will do the square of these even numbers and taking only the unit digit, we will get 2 square as 4, 4 square is 16, or we can write 6, 6 square is 36, or we can write 6 here also, 8 square will be 64, hence 4. Now 0 square is 0. Hence what we have observed, if we will do the square of an even number, we will get 4, 6, 6, 4, 0 as our ending digit in its square. And hence it helped us in the conclusion that whenever we will do square of an even number, in result we will also get an even number. So let's start with our question. Now in the question you just need to observe the ending digit. If the ending digit is odd, the square will be also odd, and if it is not, or I can say if there is an even digit, so the square will be also an even digit. So let's start with the third part. In third part we have 7779, and the unit digit or the ending digit of this number is what? Yes, it's 9. And as you know, 9 is an odd number. So square of this number is also an odd number. In the fourth part, if you will see, the ending digit of this number is 4, and 4 is an even number, so the square of this number will also be an even number. I hope so you have understood these questions. Now in next video we will learn how to do rest questions of the exercise. Till then, take care and thank you.